Mezoncheza, I'll be taking you through chapter 3 of the Rust programming language, the book. So the we are going to cover common programming concepts. So in this chapter, uh, we will cover concepts that appear in almost every programming language and how they work in Rust. So for that, let's jump right into the terminal and create a new cargo project, cargo new, and then we call the project variables. Then we move into the variables folder and open it in your favorite code editor. So first thing we are going to cover is variables and mutability. So uh, we are going to cover variables and mutability. So for that, when declaring a variable in Rust, we use the let keyword. So if we want to declare a variable called x, so we say use let, then we use the variable name we want to use, then we give it to uh, the we assign the value we want. So we have created a variable called x and created and assigned it that value, and it is a type of uh, signed 32-bit integer. So we can try to print our value. So the value of x is, and then pass in our value x. In our program, you can either use run or r, both work the same, so it will compile and execute our program at the same time. So um so as you can see, we are getting the value is 5. Then let's try uh, assigning x to another type. So you can say x. I will try to change the value maybe to 4 and try to print out again the new value of x. X is, and then pass in x. Save and try to run that. So you can see we are getting into an error saying cannot assign twice to immutable value. So basically, in every value of every variable in Rust is not mutable, so it's immutable by default. So to make it mutable, so that you can either change a value, you use the mute keyword. So you add mut before the name of the variable. Now if we try to change it and run again, so you can see we are now able to print and change the value. So so in Rust, the compiler guarantees that when you state that a value won't change, it really won't change. That means that when you are reading or writing code, you don't have to keep track of how and where a value might change. Your code is that's easier to reason through. Um, Mutability can be very useful because variables are immutable only by default, and you can make them mutable by adding the mut in front of every variable name. So as you've seen, we have done it. We are able to create a variable and change it. We can also try to create a new change again x, the value of x, and maybe put it to 10. So it doesn't matter. The most new value of x is x. There, and try to run it. If you try to run it, you can see we are able to mutate the value of x without errors. So next, let's see the difference between variables and constants. So to declare a constant, we use uh, this word. Let me show you. Use the const keyword. So you say const, and then you can maybe say the max points you want is equals to maybe 1,000 or 100,000, like so. And then using constant, you have to uh, show the type you want. So to show that the type of the value should be fixed, so you have to explicitly show the type. And for this one, we want an unsigned 32-bit integer, so it won't ever become a negative. So that's how we declare a constant, and we can also try to print it out here. So constant number is, and we pass the constant number max points, like so. So if we try to change the type, the constant type, we get an error. So let's say we want to change the max point, then is equals to maybe 10, and save that and try to run it. Let's see the error. So you can see you cannot assign to this expression. You see, you cannot assign to this expression. So once you declare value as a constant, you can never assign it a value, but you can assign a value to it. So let's say uh, max can be equals to that constant, so like so. So the variable max can be equal to that constant, and you can try to print out and say the value of marks is let's try to pass it out and see. Cover run, and you see we are able to assign that. And now you can now even mutate marks, and in here you can say marks minus equals like 1000 or 109, and you see we are able to you can see we are able now to mutate the marks, but the constant value still remains at 100,000. So the next thing we're going to cover is shadowing. So as you saw in the guessing game, uh, where we are comparing the guess and the secret, you can declare a value. You can declare a new variable with the same name as the previous variable, and the new variable shadows the previous variable. So um, let me just comment that out. Let me just comment that out and create a new fn main here. So we can create a value x. Let x is equals to 5, and then we can shadow x again. So we can create a new value. Let x is equals to 5 plus maybe 12, and if we print the value is equals to 5 plus 12, or even you can also add plus x here, plus x, and then so we can also even add more. So let x is equals to a new value of x, and we multiply maybe times 2. So let's try to print this out and print the total value of x. And we run that, so we are getting 44. So we add 5, we get 17. 17 plus 5, we get 22, and when we multiply times 2, we get 44. So you can see how you can shadow values. So we are adding these values like so. We can also try to print on every line. So you can say maybe first value of x, and first x. Let's just pass x here, and we want to copy that and paste this there, and say the second value. And if we run that, you can see we are getting 5, then 22, then x, as you can see. So that's how you can shadow a value, a variable in Rust. So next we are going to cover on data types. So we have scalar types. So a scalar type represents a single value. Rust has four primary scalar types, that is an integer, a floating point, numbers, and floating point numbers, and booleans and characters. So let's now look into the integers. So I'm going to just again comment that out. When we push it, you can read it through. So the first thing we are going to cover is the integer. So an integer is a number without a fraction component. So these integers are basically whole numbers. So in Rust we have two types of integers. We have signed and unsigned. So we have the first one, we have an 8-bit integer, we have a 16-bit integer, we have also a 32, 64, and 128. So, and then we have the arc, which covers up to your operating system's uh, capacity. So we have the I size and the U size. So for the signed, we call them I size. So let's say we have uh, a number, so let's call it signed and score int. We call it, when we say we want now maybe assigned I8 value, so we say we want maybe 3. So for signed integers, they can have from negative or positive, so they have signs in front of them, so these can also be negative like so, or even positive. So next, the other one is unsigned. So if we let's say and call it unsigned int, and for unsigned int they can never be negative. So if we save that, compiler will bring some issues. We want an unsigned, so the compiler will bring some issues. So for, if you see an I in front of the value, it's unsigned. If you an I in front of the value, you see, it's assigned. If you see a U, it's unsigned. So for unsigned, they can never be negative. So maybe that is, so that can never change to a negative value. So we have 8, 16, 32, 64, 128, and I size, which grow up to your system's architecture. So integers also have uh, integer retrievers in Rust, decimals, hex numbers, octals, binaries, and bytes, which are only unsigned 8-bit integers. So for unsigned, 8-bit, this number can only grow to 255 at most. So let's try. So this number, if it's a number with an 8-bit integer, it will grow up to 855. So if it overflows, it will cause a panic. So if we try to pass this as 256, it will throw a panic. So you can see it's out of range. So if we run, you can see uh, it says that this number is out of whose range is between 0 to 255. So if the number is out of range, the overflows, the compiler will throw a panic. So you also have floating points. So to declare one, you say you want a floating number. You can declare it like that. If you add point, the compiler will automatically know it's a floating point. But you can also do it explicitly. Call it a point, and you can also give it a type. A type like you can give it the same the either 32, 64, 128. So let's give this a net 32 like so. So if you strictly give the value the uh, type, the compiler will take that type you've given it. So next we have numeric operations. So for that you can generate values from numeric operations. So let's is equals to 0, like 1 plus 3. So this is sum. You can also add from subtraction. So you let subtraction is equals to 10 minus 20 minus 10, right? So you can also have from division, let if is equals to maybe 20 divided by 5, and then you can also take it from multiplication. So let product is equals to 2 times 10, like so. So that's how you can also generate numeric variables. So you can also have booleans. So let bool is equals to false. It will know it's a boolean or true. So booleans can either be true or false. So we also have the character type. So characters can hold values, uh, any character that is let car is equals to maybe z or a, and you can also holds even you can also hold even an emoji. So let's say so basically characters hold from A to Z and even 1 to 10. And give it maybe 2. Maybe it's a number this time. So that is what the character holds. So they can be 1 A to Z or 1 to 10 or something like so. So next, let's cover on compound types. So we are going to cover on tuples, the tuple type. Let me just comment that out and create a new main function. So now the compound types can group multiple values in one type. So Rust has two primitive compound types, that is tuples and arrays. So the tuple, a tuple is a general way of grouping together some number of other values with a variety of types in a compound type. So tuples have fixed length. Once declared, they cannot grow or shrink. So when declaring a tuple, let's say we use still the let keyword. So let tuple is equals to uh, we want 300. We also we want a floating point, and we also you can also have an number, any other number there. So you can also have a boolean if you want. You can let the compiler explicitly give its own type, or you can also give your own types like so. So we want the first one, you can say you want it to be maybe a boolean, then the next to be a floating point, then next to be unsigned 8-bit integer, and then the next to be assigned 32-bit integer, like so. So when we save that, this value should be a boolean, so this should change, and we put maybe true in here, and it can be now the value like so. So that's how you create a tuple. And when you want to get tuple values from a tuple, how you need to destructure it. So give your values maybe x, y, we have 4, u, and z as equals to our tuple. So you can now print your values. So print x, um, y, we also have u and z. You can just print all of them. Y, u, and z. That's how now you can get data from a tuple using when you destructure it. So if you run that, you can see you get in true 34.51 in 20. You can also access the data using index. So you can print it like so, like this, and the value of x, we take the tuple at index 0. We also take the tuple at index 1, tuple at index 2, then tuple at index 3, like so. At index 3, like so. If we run that, so we are still getting the same output. So let's cover about arrays. So this was about tuples. Let's comment these tuples. Now let's create a new main and for these arrays. So in arrays, in arrays, uh, arrays is another way of uh, collecting multiple values in Rust. Unlike tuples, every element of an array must be of the same type. So arrays store values of the same type. So let's say we want uh, our array, but it will hold only a signed 32-bit value. So it's we now give this to that. So we say 1, 2, 3, 4, 5, like so. So you can explicitly give the type, or you can automatically, it can be given by the compiler 1.0, 2.2, 1.4, 1.5. So for that, for the first thing in an array, you have to um, the first thing you have to show the type. So we want an i32, and then give the number. So we want 5 values in that. So we can, with the first in an array, you show it in a square bracket. So the first thing you show the type you want, and then the number of the array. So arrays length don't grow or shrink at runtime. So you can also have an array of weekdays, like let week let's so you can see they all have different types, so but they all have to match. So if we try to maybe add an integer here, the compiler will shout say mismatched type. You see, like so. So accessing the array, let's try to access this. So we're going to print the 5th day. Okay, the first day, then we take days. and then we take at index 0. So this will take the first day at index 1. Right, so let's try to run it, and you can see the first day is Monday, like so. So that's how you can access values in an array, but remember that using the index, so they you cannot it cannot grow or shrink. If you tried passing an index that is bigger than the amount of number, so let's say even 5, because we are starting to count from 0, 0, 1, 2, 3, 4, it should panic, so saying the index is out of bound. So basically I think we have we have declared all the